Okay, it's time to add some vocabulary to the things you understand about angle relationships. Our first vocabulary word is vertical angles. These are really important to understand. Vertical angles are formed when you find two straight lines that have intersected. Let me show you. So here's a line, and here's another line that's crossed through it like an X. So when you do that, you've made some angles in there. And if we don't include the vertical angles, you should see 4 different angles. Let's number those 4 angles. Let's put angle 1, 2, 3, and 4. Now, vertical angles are always formed by those intersecting lines, and they're the angles that are found opposite one another. So which angles are opposite each other in this? You can see angle 1. Here's angle 1, and it is directly opposite angle 3. So angle 1 and angle 3 would be considered vertical angles. Then we see that we have angle 4 here on the left, and angle 4 is directly opposite of angle 2 on the right, making angle 4 and angle 2 vertical angles. Now, I just misspoke a little bit because I was going to save that, but I'll talk about it now. Angle 4 and angle 2, vertical angles here, are congruent. If you think about the X that you've made, you've got this like scissors. When you open up the angle or close in the angle, both of them change together. So these two measures, angle 4 and angle 2, would be congruent. In fact, let's change our and there, and let's make that say congruent using our symbol. So 4 would be congruent to angle 2 because they're vertical angles, and the same goes for the set of angles 1 and 3. Those would be congruent also. One more time, vertical angles are formed by intersecting lines that cross through each other and form those angles opposite one another. Those are vertical angles. Make sure you have that written down. You'll need to know that definition. Our next definition is for the word complementary. You may have learned this one before. Complementary angles are formed when you have two angles, and this is a relationship based on the measure of those two angles. If I have one angle that is measuring, let's say, 30 degrees, and I have a second angle measuring 60 degrees, then those two angles would be considered complementary, because the definition of complementary is that they add to 90 degrees. Two angles that add to 90 degrees, like this example. Now, another type you might see it would be if they are put together with their vertices together, and they form a right angle together. So we would see this square. And in that case, those are definitely going to be complementary because it takes both of them together added up to equal that 90 degrees. So let's say this is a 70-degree angle. With that angle addition postulate we learned last time, this would be a 20-degree angle. These are examples of complementary angles. They have to add to 90. The next one is similar to that. It's supplementary angles. You don't want to confuse these, but they have similar definitions. Let's say I have an angle that measures, we'll call this 30 degrees again. The supplementary angle to that would be one that would finish off the 180 total that we get in the straight angles. So to finish that off and make it 180, it would have to be a 150-degree angle. So that would be its supplement. And then we would call these two angles supplementary. And they're called supplementary because they add together to make 180 total, to finish off a straight line. In fact, if you had a straight line, and you had two angles coming off from that straight line together, let's say that we have one angle here measuring, let's call it 125 degrees. Then the second angle, since it's forming the straight line with that first angle, and the angle addition postulate would make this a 55-degree angle. So here's another set of supplementary angles. Adjacent angles comes next, and you've actually seen a couple of examples of that. Adjacent angles look like this. Angles that are all formed by coming from the same vertex point, and they share a side. In other words, it's like they're neighbors. To be an adjacent angle or to be adjacent means you're right next to somebody or right next to something. So these two angles, and I'll just number these, they don't have any relationship in their size necessarily, but angle 1 and angle 2 are adjacent angles because they share both this side right here, That's their neighboring fence line, and they share this vertex. So angle 1 and 2 would be adjacent angles. Here's an example that are not adjacent. If I had angles like this, like a Z for example, these two angles, let's number them 3 and 4. Those would not be adjacent. Why are they not adjacent? They share a side like neighbors would on a fence line, but what they don't share is a vertex. So these are not adjacent. And I'll abbreviate that. So the definition of adjacent is angles that share a side and a vertex together. And we use adjacent angles when we use the angle addition postulate that we've practiced. Okay, linear pair. Linear pair is a combination of two of the words we've just discussed. First of all, let's write their definition. They are adjacent. And at the same time they're adjacent, so they're neighboring angles, they're also supplementary. Remember, supplementary means they add to 180. So what would a picture of that look like? I have to have two angles that are adjacent. So first things first, they have to share a vertex. Let me start by drawing one angle. And then sharing a vertex here, so I have to come off from this one, and they have to also share a side. Let me say they share this side. Then I would need to have it look like this, because they have to add to 180. They have to be adjacent, like these are, and supplementary. So how many degrees are in these two angles together? Do they add to 180? Well, we can see that they do because they make that straight line there. Let me highlight their straight line that they're forming right here. Together, they make that straight line. So let me draw another example of a linear pair. So they look a little bit different situation. Here's another set of a linear pair. These two angles, let me number them, angle 1 and angle 2. So here's two examples of linear pairs. They're supplementary. They're always going to make that straight line together. And they're adjacent, so they're going to share one of their sides. And the other two sides are going to be opposite one another in a line. Finally, perpendicular lines. Perpendicular is a word related to lines, but angles are very much tied to them. Perpendicular lines means that two lines or rays are intersecting to form that right angle that we like so much. So these two lines would be considered perpendicular because they make this right angle. Lines are also considered perpendicular when they're just parts of those lines, like rays, for example, or segments. So these two lines here, these would be considered perpendicular, again, because they make a right angle together. So perpendicular lines are always going to form that 90-degree angle. Now the symbol for perpendicular, this is a new symbol for us. So let's name these lines so I can show you how the symbol works. Let's call this line A, and let's call this line B. I would say that line A is perpendicular, this upside down T, line A is perpendicular to line B. Or over here on this one, let's call this line M and line N. Again, line M is perpendicular to line N. And those are your 6 vocabulary words that we're going to be working with in the next couple of days.